Hello, my given name is Ian, and I'm making this presentation under the Equal Protection Clauses of the Constitution of the United States. And with the flat Earth debate that's on the internet right now, I just thought I'd like to go over some points for everybody. I brought up a picture, I downloaded a picture off the internet here. So here we have the horizon line along here, and some islands in the background, and the sea. And this is basically a fairly close to what I call a level picture. As you can see, the horizon line was placed about approximately halfway through the picture to give a balance. Now, for the curvature of the Earth, seeing is believing. Now, in the earlier video, I did maps. I mentioned that maps are inaccurate. They're not navigation charts. Now, if you go into a government office and you look for a topographical map, they may have, they'll bring out a large map of your state or province, and then they're broke down into sections, and they're called grid reference maps, topographical maps. So you want to get a topographical map for the location where you're presently residing, and you can look at elevations, and elevations will give you your curvature, which is in surveying it's called a grade, or like when you look at a highway, a highway will have 2% grade, meaning it rises at a certain level, which is, although they try to get it as straight as possible, there's curves on roads. In the natural solid terra firma, which is Earth. Earth is the ground we walk on, and water is part of the world we live in. And because of the way words can be manipulated, right here, along here, this would be the curvature of the Earth. If you go and you take the height here from the sea level to the top of the mountain, whatever the elevation is, and then the distance, and then this would represent, say, the curvature of the Earth. Now, when you take theoretical physics, you go out into the field and put them to work, what that means in this respect, you want to know, we're talking about the curvature of the Earth, which is being represented here, and the spin of the Earth, which will be represented when you get to the bottom here at sea level, and you go to work, and you're going to go against the natural spin of the Earth, so you're going against the spin, so you're going uphill, and next work, and all physics, your high school physics all come into play here. Work, it's no longer theoretical physics, it's real physics. So when you get up to your top of your location, and you take a level view of what you're seeing, if you're along here, that would be your level now. And as you look into the distance, you will see a horizon. And people are pointing out, as ships go over the horizon, they disappear. Now you can take an eye chart, and you can set it up at the end of a room, and as you're going down, the levels, starts out with the big E and the second line. That represents, you don't even have to move, but as you go down line by line by line by line, you can actually say that's the distance. And then when you get to the bottom, you can't, the letters all kind of look like a line, a horizon line, actually. How here, it could be a rough, stormy day out here, but it's still over distance. Those waves diminish in size to your perception and give a level horizon, no matter where you are. And I'm going to bring up another photo here. I downloaded. And again, here's the beach and the water line. And in this picture, the photographer moved the horizon higher up in the picture to bring in the chairs and the beach line. Make it the shallow. The water's a little more shallow, so you can. There's a little bit of a color change because the depth of the water as the light goes down and comes back up. It's changed. And again, an island in the background. Another grade. And I'll turn up another photo quickly. And in here we have a man in here in a boat. And again, the horizon. And a grade slope here. This one, look, more what you might think what the curvature might look like. Now, here I wanted to point out, we have the element of water, and water is dynamic, it's moving, it has various states, and water being evaporated into the atmosphere, which form the clouds. And when it rains, you'll have the rain coming down, and if you actually, at the end of a rainstorm, as the rain starts to lighten up, and you look at a leaf, and you'll see the water coming off the leaf as it's coming down, and then as the gradually as the rain lightens up, you'll see the stream of the water will start to break up until eventually the surface tension starts to build the water up to a point where it goes into looks like a globe, which helps reinforce a globe's view. That's not reality. It's the surface tension of the water in that little raindrop, and then finally what we perceive as gravity brings it back down. But water being dynamic, it's going it's going up into the sky, and if you calculate 1 inch of water rains over an hour on an island like this as it's flowing off, and you calculate the volume and the weight of water that's coming down, it's really phenomenal to think how much weight that you see flying over in the clouds. And I have a video here that I took yesterday. Now, before I start, there is actually, you can see, there's a slight slope here, which is close what I think what they might have as the curvature. So I'm just going to start here. And here, you can barely see, but this is the water line across, and it's a cloudy day yesterday. Now here, you can see the grade of the road as it's going up. The natural curvature here and the level. These buildings are level here. It's more noticeable as I go along here. So I turn it off. Okay, and I'll just stop here. Now, here, the building level, you can see how this guy is, we'll go 6 feet, make it easy for rounding numbers. So you can see how the building here with the facade, or that's the wrong. But the different stories. these are level. Inside here, it's a level building. The curvature here, and again, you can see, as we're looking, you can see the curvature. You can see the grade. You're at a lower elevation. You're looking up at a higher elevation. It's just a way to. You have to go into the field and start thinking again. Put your thinking caps back on. When you're walking uphill, the spin of the earth at the bottom. As you're walking uphill, you're going against the spin of the earth. You get to the top, and you turn around, and you start heading down. It's much easier walking downhill with the natural spin of the earth. But again, you're under the delusion that the earth is moving. You're moving, going downhill, and people are on their way, turning around, they're looking up, and you're in the way, as they say. You have to put your thinking caps back on, and simple human anatomy. Everybody's got two butts, and everybody knows what two butts hide, and needs to correct errors. This is the fundamental principle of the law. So it's back to the ABCs, and good luck with your studies, or there's no luck involved. It's just you're intelligent. Don't let anybody fool you about that. You can think for yourself. You're not the President of the United States.